So here we are again. Just take a few seconds to make sure that we're live. Get the chat out, check the audio. 2, 3, 4, 5. 2, 3, 4, 5. Very good. All right. So next question is minimum cost for tickets. Let's see how this goes. This one is, I did not actually look at the question yet. So we'll open this here. Also refresh this while we're looking. All right, minimum cost for tickets. You have planned some train traveling 1 year in advance. The days of the year in which you will travel are given as an integer array days. Each day is an integer from 1 to 365. Train tickets are sold in 3 different ways. A 1-day pass is sold for cost $0. A 7-day pass is sold for cost $1. And a 30-day pass is sold for cost $2. The passes allow that many days of consecutive travel. For example, if we get a 7-day pass on day 2, then we can travel for 7 days, 2, 3, 4, 5, 6, 7, and 8. Return the minimum number of dollars you need to travel every day in the given list of days. Ooh, that's interesting. Okay. Huh. Oh wow. So we have a days from 1 to 365. We have these costs. Oh man. Days is in strictly increasing order. Days is between 1 and 365. 1 days of ice. Yeah, less than days cost is 3. They don't have the costs are in strictly increasing order. That would be a little awkward if the costs are, if it's lower cost to get a longer pass. Oh my goodness, that would be kind of funny. It actually doesn't say that. Presumably it is. I mean, it should be. Cost should also be in strictly increasing order, but they don't have to be according to these constraints, which is a little bit annoying, a little bit awkward, but all right. This, you could do this in quadratic time if you had to. But I think you could do this in linear time. So basically, what you're gonna try to do is group the excuse me, oh my mouth, ow. Group the days that you have. I think you could do a greedy algorithm. Start from the smallest day that you have that you need to cover, right? And you can either pick, you have 3 options. You can either pick the 1-day pass and continue from there. Maybe dynamic programming, actually, I'm not sure. 1-day pass, 7-day pass and grab all of those days, or the 30-day pass and grab everything, right? And get the associated cost. Each of those choices, then you would move to the next day and do the same thing, right? And decide which one's which. And I guess you could go backwards and say, okay, like, well, maybe not backwards. I think, I don't know, maybe just a greedy algorithm is fine. I'm trying to decide if it's a greedy algorithm or dynamic programming, probably one or the other. Because you have $2 for 1 day, and now you're at this position with $2. And you probably could actually, like, because it's 1 day, 7 day, and 30 days, you could probably use doubles here and just calculate the amount of cost you get per choice, and always just take the optimal choice. So with a 30-day pass, you get 1, 2, 3, 4, 5, 6 days for 15. So you get a sort of cost benefit of 5 of the elements, 1, 2, 3, 4, 5, 6. Excuse me, 6 of the elements that you need at a cost of 15. So how much per day? It's 15 divided by 6 is 5 divided by 2 is $2.50 per day. The 1-day pass is $2 per day, so you wouldn't. So that's already better to just buy $2 each day. Would be better than 15. But also, if you got the 7-day pass, 1, 2, 3, 4, you get 4 for 7, which is better than 2, right? That's like 7 divided by 4 is like 1.75. So you would get 1.75 for the 7-day pass, and then you can do $2 for each of these, right? Obviously, if you did 2 for $7, it'd be $3.50 each, and same thing, 2 for $15 is $7.50 each, which is too much, more than 2. So in both of these cases, you would take 2. You could do something like that too. I don't know if that's entirely correct though, because I suspect the problem that you run into if you do it that way, just very straightforward kind of greedy algorithm, is I think there are test cases where it doesn't work properly. And excuse me, and I think the reasoning is excuse me, and you can do technically this would be linear time, even if you looked 30 days ahead every time at every iteration. You could actually do a binary search to jump all the way ahead to figure out how many elements you get. It's a little bit more efficient if you do it that way, which I think I'm going to do it that way. I'm going to use the binary search, I think. I'm thinking, but the idea is I don't know that a strictly greedy algorithm is entirely correct, and the reason is that maybe it's more efficient at one point to get a 30-day pass to get all 30 days, but then maybe after those 30 days there's like a gap where you don't really want to get a 30-day pass, right? And then there's another point where you do want to get the 30-day pass. Well, it could be that actually you should wait a few days and then get the 30-day pass. Like there might be 7 days that's better to get the 7-day pass, a few days to get the 7-day pass, then get the 30-day pass, and then whatever, go from there. And I think it's possible to construct a scenario like that where it's actually not optimal to go for the strictly greedy strictly greedy approach. You probably could still do a greedy approach, but not quite that way. Yeah, and I think yeah, that basically would be like, yeah, it's better to grab 30 in one shot. But yeah, basically, like you could find yourself in a situation where it's always more efficient to grab 30 at any point compared to any other option. However, if you grab the 30 later on, then it would actually be more efficient than grabbing it earlier, in which case you probably just want to use a dynamic programming solution. So a dynamic programming solution would just be there are different ways of doing this. You could say you can go backwards and start from the largest value and then update the dynamic array with go back 30, go all the way back to 0. Obviously stop at 0 and update it with 15. And then you can also go back to 13, the 7-day pass from 20. That's not quite right. No, that's not quite right. Trying to think how to do the dynamic programming correctly. Not so obvious how to do that. Because 30 days would get you all the way through for 15. That would work. 7 days from 20 would put you at 13, which is actually nowhere near 8, or it's not 8. It doesn't cover 8. That would put you 7 for 20, and then you'd have to go down from that point 13 down to 8, quite frankly. And I'm wondering if maybe each iteration, I just go through all those days. You could do at each point. Again, it still would be linear time. There's probably a more efficient way to do it. Like you probably could do a binary search to figure out where exactly does 7 days, where does 13 put me at? It puts me at 8 here. And really, you're just looking for the index. You don't even necessarily need to find the you don't necessarily need to find the exact value here. It just so happens that these values, both the days and indices, are kind of like pretty limited, we'll just say. So you can go 20 to 13, and that gives you a cost of 7. And now your DP array, I guess, you have 13 of cost of 7 at this point, and then you want to keep going back further. And again, your choices are 1, 7, and 30. And we can go through that in a moment. But if we just picked 1, we would go back to 8 again, right? 19 would go down to 8, and there would be a cost of 2. So actually, we would update that 8 with we do all 3 of these options, and notice that we can get to 8 at a cost of 2, and then we can also get to 0 at a cost of 15. And then we go down and look at 8, and we say, okay, from my best cost of 2, now update the different possibilities again, the 3 different options again. Yeah, again, you could save a little bit of time using a binary search, but you really don't need to, quite frankly. You can just kind of go right to left from that point until you've sort of you got down to an element that's less than or equal to, in the case of 20, element that's less than or equal to 0. In the case of 20 and 30, in the case of 20 and 7, less than or equal to 13, and in the case of 1, less than or equal to 19. And just update that element in the index of that element in the DP array. That works too. I mean, that's pretty straightforward. I don't want to spend too much time on this one. There's probably other ways to do this that are clever. We don't really need to spend too much time. N is going to be days. DP of n, fill this with zeros. Actually, probably want the greatest cost. What's the value of the cost? It's like 1,000, and this could be like, let's say 40,000. We'll just say 40,000. And 40,000 is 10,000 times 4. Bit shift to left 2 bits. So 40,000. This should be fine, big enough number. And then we're gonna say go back to front. N I is greater than or equal to 0. Decrement I. We're gonna return DP of 0, and we're gonna say for each of the costs. We'll just say int A is costs of 2. I guess you don't even need to do that. You could just do all the costs, right? Even go further than that. C in costs. We're gonna take a loop for j equals I minus 1, days of j, const int val, or target, is going to be days of I, current days of I, current day minus c, right? So yeah, 20 minus 7, you get 13, 14, 15, 16, 17, 18, 19, 20. That's 8. So actually, it's not quite right. It should be the 7-day pass would take you to 8 from 2. 8 minus 2 plus 1 is 7. So it's actually a little more sophisticated. I think it's more like this. Minus c plus 1. So if your current day was 2, you would want to go down to oh no, wait. Am I crazy here? Hold on. Hold on a second. I don't know if I'm doing this correctly. I want to include that day, right? So I think I need to actually do something more like this. Is it more like this? I'm a little confused, actually. Let me think about this. Gee. You know, I'm not sure. Maybe I should go in the other direction. What is the cost? To get to where? Oh, that's confusing. Okay, I could try doing the backwards direction, and I could try doing the forwards directions. I think the backward direction. So at 20, what do I write at dp of I of 20? Well, it's actually not dp of I of 20 that I want to write to. I want to write to the dp of like 13 and 8 and what have you. At those indices, really indices for 8 twice, and then one of them actually goes all the way down to 0, dp of 0. How does that work exactly? I think I have this. I understand the step somewhat, but I don't really understand the starting point. I don't fully understand the step either. Kind of getting a little bit confused. The induction here. So let's say it was just one day and it was 20, day 20, right? That's actually index 0 immediately. Yeah, it doesn't really make a lot of sense. The way that I've kind of described it, or tried to think it through. Yes, you could technically work backwards, but how exactly do you do that? You want to spend one ticket with some price to get this day, right? The ith day, the last day, right? And you could spend a 30 ticket, you could spend a 7 ticket, or a 1 ticket, right? And what that would imply is you have a certain cost associated with, I think there's a current cost to get to that point, right? Which we'll say at the moment, yeah, I'm not sure about that actually. Let's say it's the cost past that point. So once you've gotten to that point, to include all the days to the right, that's the cost for dp of I. Not including that point though. All the days to the right, but not including that point. Interesting. That would make things a little bit confusing because you probably would want an extra value now. You'd want an extra DP value where you have basically index -1, where you're looking at everything to the right. Cost of getting everywhere, getting to the right of -1 is what you want, but then all the indices have to be shifted, which makes things pretty confusing. Quite frankly, it makes things very confusing. Instead, you could do the cost to get to that, to include that day and everything to the right. In which case, you would just want to have one extra value, index of I, that starts off at 0. And yeah, this should be -1 normally, but we can start at that value. And then now it's a little bit easier to think about. Yeah. So it's going to be the cost to get to that, to process that day and all the days to the right. That's going to be the minimum cost to do that. So then from 20, excuse me, yeah, so from 21, more or less, it starts off at 0. But what's interesting is the current day at I doesn't exist, right? That's definitely gets more interesting there. We could say days.pushback. Days.back +1. Just have an extra day. Doesn't cost anything to get there. And then now days of I has a value. And then the cost has a certain value for the cost. And then the target day then is going to be this current day minus C. So in this case, I want to include, I want to get to 21. So I actually don't need, yeah, so that actually could just be the back put there twice. Really. Yeah, it's not obvious actually. It's a little confusing. Let's say I just put 20 in there again, right? Now the cost to include that day and everything to the right is 0. Does that make sense? I don't know if that makes sense. When I look at the DP of now, when I want 13, 14, 15, 16, 17, 18, 19, 20. That's 8. It should be basically 14, I think. 14, 15, 16, 17, 18, 19, 20. 14. So it would be minus C plus 1. The target day would be 14. So now to calculate for the DP of 14, which actually in this case should be 8, this is so confusing. Oh no. Oh my goodness. What a pain in the neck. This is not working. Not working the way I would like it to. Gee. Okay. Huh. Fairly certain you can use a DP solution here, but I'm just kind of having an issue getting it straightened out exactly what it should be. Cost to acquire a certain day and all of the days to the right. The minimum cost. Okay. Then you could look 7 days to the left, 30 days to the left, or 1 day to the left, and reason about the cost to include that day and all the days to the right. And it would be it's so confusing. Oh no, I don't know. Okay, I'm just gonna take a moment because I got confused. That's just a lot of. That's a good question, actually. It really makes you think. I don't think it's that hard. It's just like the logic is kind of involved. There's a lot of kind of elements to this. Because there's kind of like a jumping thing going on with the days, the values. You're like skipping days at points. Well, gee, I don't know. I'm trying to think about how to do it backwards, but I'm struggling. Maybe I'll just go forwards. Just forget backwards for now. There's probably a way to do it backwards, but I'm taking too much time figuring that out. So we just go forwards. Okay, you have some day number, and the options are you can go buy one ticket at different costs, and that'll give you a whole bunch of days, right? You can kind of move forward to some point. And so the cost to reach a particular day but not include it is going to be what the DP value would be, I think. At a certain index, reach a certain index but not include that index. And then to calculate this value going forward, you would say, okay, we include this day, and then I'm not sure. I actually don't know. It's a little more to this than I thought. I'm thinking about it. I don't know if a DP is quite right. I don't know. I don't know about that. Yeah, basically, you can. Yeah, the min cost to get to a certain value but not include it. So initially it's 0, right? First value is 0 because you're not including it. It's no cost. Then a 1-day ticket would take you to the next day. And you get 1 so it includes all the days to the left except the one that you're at. So you go to the next. You always go to the next largest value, right? So even if the next day is greater than 1, you're still going to go to the next index. So for a value of 1, let's say your day is 8 and the next day is 9. It could be 9 or 10. Let's say it's 9. Then your 1 would go straight to 9. And you would update that 9 with a 1, right? Then you can go to not with a 1, with the cost of 1, right? Same thing for if it was 10, you would still update the 10 with a cost of 1, right? Because it would be the cost to get all the days to the left without including that day is the cost of 1. Is the cost of 1 ticket, right? Then for 7, you do the same thing. You would loop left to right through each of the values. Really, you could do a binary search to find so that if your initial day was 8 and you have 7 days now, 8, 9, 10, 11, 12, 13, 14, I think. So you would add the cost minus 1 to that value, right? Or the not the cost minus 1, the length minus 1. Excuse me. Yeah, that's another issue here, is the cost as well as the number of days is relevant. I'm using the wrong, I did it like day plus C or day plus minus C, whatever it was. Those are the wrong units. But yeah, you would add, we'd add 0 for the first one, and find the upper bound on 0, or 8. Right? Add 0 to 8, find the upper bound on 8. Then add what's the word? Add 6 to the day number and find the upper bound on that, and that's the position that'll get updated there. And then finally add, you get the upper bound on 30. Update the position there. Each of those things will then, those are all the DP values. So I'm going to get those are the days in which a day should be updated, the index of the day that should be updated, and then also there is the amount it should be updated. I'm going to add to the value that I have currently. I'm going to add the cost to that value I have currently, and then take the minimum of what's at that position, the new position, we'll call it. Whatever values of that new position, check that against this this calculated value, and then take the smaller of the two. And so I can update, 3 different spots, in logarithmic time, right? So that's all well and good. That'll work. One question is, what about this would still be linear time, by the way, this whole thing, because the difference in value is a small constant, even though the logarithm call that's being made is logarithmic call is looks like it would be logarithmic time. It's not actually logarithmic. It's like a constant. But anyway, so can update the DP values, right? But when do I stop, and what about if I go too far, right? Like, what if my upper bound value goes all the way off the edge of the array, right? What about those cases? So I stop once I've processed every index. That's number one, and update whatever values are to the right. I think I can add a day to the array as well. That's just a day that's it's not included, right? And I think if I'm off the edge, I just always go back 1 to that day. And that's actually the day that I want to return. I think that works. I realize that's confusing. Let me try that. Let me try something like that. It's quite the algorithm here. Quite the idea. So okay. First things first. Let's do dpn plus 1. Days pushed by days back plus 1. These could all just be zeros now. And no, actually, never mind. I had to write the first time. First, the initial position will be 0. This is now going to go from the forward direction less than n. Return dp of n Also going to have int tickets array 1, 7, and 30. And here we're going to say for each I, have the current day, the current cost, and this is going to be now int j equals 0. J is less than costs.size. We get target day is going to be the current day plus -1 plus tickets of j -1, and then new cost, the current cost plus cost of j. Okay. And now we say int index standard find. It's actually going to be upper bound, I think. This gives me an input. Okay. Gives me an iterator. I think upper bound also gives me an iterator on. Go to the algorithms library. Yeah. Okay, algorithms library, you're looking for upper bound. So I use this on an array. Does it give me an index? I don't know what I get. Oh, I know what to do, actually. I know what to do. It's not an integer. It's like a int pointer, really. Pointer, we'll say. It's going to be find on days plus I. No. Days plus I to the end. Days plus I plus dx of j. That's a little confusing, yeah. That's the part that I meant, that this is constant. It's like logarithmic over a constant amount. Right. So it's, yeah, the number of indices is, it cannot be more than tx of j. And then the value is going to be the target day. We're looking for the day next to it. We say if pointer is equal to days plus n, then just set the pointer to days plus n minus 1, something like this. The index is then pointer minus, I think, days. That gets confusing. This is actually not an array. Days is not an array, so I can use that's confusing. I think there's a find somewhere in here. Is there? No. Okay. So actually, this is going to be find, not days plus I, but days dot begin plus I. Days dot begin plus I plus transaction or ticket days of j. Let's think about this again. So Excuse me. If my day is 8 and my ticket is 7, excuse me, that can take me to at most 14. 8, 9, 10, 11, 12, 13, 14. Okay. That's 7 days. I want to go past that. Days that begin plus I is 8, and then add, instead of adding 6 to get to 14, I would add 7. But this actually goes a little bit further. This is yeah, so this could be I'm wondering if I want to go even one more than this. Because the problem I run into if I do it this way is this could be really should be stopped at days.begin or days.end, and that's where things get really confusing. Gee, okay. Yeah, it gets really confusing. That is very confusing. Gee. Oh boy. This also is int new index offset. So if the offset auto end pointer step begin. So if the offset is greater than this is confusing. I don't know if I should do it this way. This is like a lot of extra effort for something that probably doesn't need to be this complicated. Probably should not even use an upper bound. Should just use a find. Find routine is fine. Just keep this simple. We'll just keep this simple. Oh no, that's not. Is there find if maybe? This is so much more complicated than it needs to be, or making this a lot more complicated than it needs to be. Find. Let's do find. What if like find a first, or find if, find last, first if. I think this is of a set. Yeah, I don't want that. I want the first. Element equal this value, predicate is true. Okay, could do find if and just do less than. Days begin plus I, days end, and then it's just going to be it's greater than the target day. Just X is greater than the target day. That works too. That's fine. You don't need to make things so complicated here. Then yeah. Also a little bit confusing. Explain that in a minute. Get the index. Okay, yeah. So this is yikes. Okay. All right. We're gonna search. We have this target day. We're looking for the first day that's greater than that target day. So find if each of the days starting from this point. Yeah. And if we go off the edge, right, there should be an extra day here. If we go off the edge, then we just go back to that extra day. We update it. We get our index. And we're going to say dp of this index is going to be smaller of dp of index plus this call, not dp of x of the new call. It's going to be this, yeah, what's there already, and this new cost, which is this current cost plus cost of j. Okay. It took me a really long time to just program that. But for whatever reason, that was kind of complicated. Something like this is what I think I want. Took a really long time. Oh, this is a double? Oh, really? Okay. Wasn't expecting that. That's fine. Don't need to spend too much time on that one. Something like this. Wrong answer. No. No. Really? Well, huh. No kidding. Well, that's awkward. No kidding. Huh. What? Both of these gave me 0? Does this do anything? Did I? was kind of concerned about that maybe this code doesn't do what I think it does. Let's do something, anything. It also should be, oh, I see, +1. That's why. Yeah, I kind of wonder, actually. That's confusing. I probably should, because I'm pushing another day back too into the days array, so that's even more confusing. Still 0, huh? 0. Why is it getting 0? What's going on? Let me do this. These could just be n. Get things a lot simpler. And yeah, we could do everything except the last element doesn't need to be touched. I think this works. Do it this way. Still works. Should be the same as the last one. Doesn't work though. I don't know why. Huh. Does this ever get called? This should be happening. I don't know what's going on here. Like I'm just getting zeros everywhere. This gets called a lot. Huh. What is going on? Costs are not 0. The tickets are not 0. What's happening? I don't know what to say. What? How do I get 0? How do I get 0? How did that happen? Let's do it this way. Let's just debug and see. Let's just see after each iteration what the array looks like. Okay, what happens if I do this? Also, wow, I'm spending a lot of time on this question. I didn't actually mean to go this long. This one. Why is the last one just always 0? What is happening? What? What? Oh! Duh. Oh my goodness. I totally... Okay. I don't know, man. Sometimes it just doesn't register what's going on. That's goofy. Alright, that was bad. Let's try some random things. Try some random stuff. I don't know. All right, these all seem to be correct and relatively efficient. Did I just submit this? I don't know. Tempted to submit it. I think if I submit it though, I'm gonna see some weird things happen. Like what I'm concerned about is like some use cases that I missed, some kind of edge cases and things. I have to really sit and think about this for a while for some edge cases. Let's not be lazy, right? What are some things that I need to test for? Well, what about when it goes off the edge? I think I have that handled correctly, right? Yeah, let's do that one right now. This one is handled correctly. It's already does that properly. That's fine. Goes off the edge. It handles that right. What about when I was saying that test case where you'd want to have 30. 1, 2, 3, 4, or let's do like, I don't know, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, right? You'd want to have 30, take care of this with 30. Let's do 1, 7, and 30, right? But you don't want to start 30 too early. So you have something like 8, 6, and 4, right? So you want to handle these in a certain way and then do 30 here. Something like this. It's kind of a test case. Alrighty. Oh, it goes through 19. Oh. Let me actually make this like 25 and 10 and 2, something like this. Okay, I didn't have enough elements to go for 30. Go straight for 25. Oh yeah, this goes all the way up. Whoops. This should be like 20. Kind of did that wrong. Interesting. So we go 2 and 30. Cool. All right, I'm gonna submit this. It could be wrong. Could be something I missed, something subtle. Oh, nope, got it. Not bad. Sweet. All right, I'll submit that like 5 times. I think, yeah, I don't know. This is pretty. I spent a lot of time on this. I don't know. There you go, 100%. Very good. Hail victory. Hail victory. Very good. All right, let me submit this a few more times. Yeah, I don't know what to say about this other than like a kind of I don't know what else to say about it other than I'm glad I got there. Obviously, you could do a little bit more with the you could do something with this upper bound, but I think the extra if statements are not really worth it, especially at such small numbers that you're working with. It's not really worth trying to add the extra logic for the logarithmic search. Yeah, this works. This is okay. This is like a little awkward, but it's reasonable. It's fine. It's a simple DP solution. I don't know what else to say about it. Just add an extra value at the end to kind of keep things simple. And I went with just update. The DP is just going to be the cost to get everything to the left of this point, but not including this point, the minimum cost. And yeah, and you can just do a simple left to right search because you don't really have much. You don't really have that many costs to consider, and you don't have that many. The ticket lengths are not that long, so it's not that hard to just do a really straightforward linear search 3 times. It's and end is pretty small to begin with as well. So between those those things, it's pretty straightforward to go for something like this. Yeah, you could think of other ideas, other approaches, but but this is fine. Yeah, okay. It gives me 100%, so not bad. Yeah, very good. I'll submit it one more time. Got a lot of votes. People really like this. There may be other solutions that are good. Maybe I should look at. I think for now I'm just gonna. I think I'm gonna stop here. So yeah, thanks for watching. Talk to you soon. Have a good rest of your day. I think that's gonna be it for me for today as well. If you like the stream, don't forget to like it and follow. And yeah, that's about it for me today. I think I took longer than I should have for this. I could have come up with that a lot faster. That wasn't too complicated, too difficult. I just, for whatever reason, was like trying to make it faster than it needed to be, or trying different things, different ideas. But yeah, okay, all right. Take care. Talk to you soon.